Good morning, students. Today we are going to learn about the enzyme catalysis. It is coming under the topic catalysis. Enzyme catalysis, it is an example for homogeneous catalysis. We know that enzymes are a special class of proteins. They catalyze, control and direct various biological processes like digestion, respiration, etc. So they are known as the biological catalysts. Then enzyme catalysis, the reactants is known as substrate. Then mechanism of enzyme catalyzed reaction. That is how an enzyme catalyzes a reaction. In 1931, L. Michaelis and Miss Maud Menden introduced a mechanism to explain the reaction of enzyme catalyzed reactions. This is known as Michaelis-Menten mechanism. This mechanism involves two-step process. Even though the enzyme catalyzed reaction is a complex reaction, then they propose that there's two major steps. The first steps in which the enzyme and substrate complex combines together to form an enzyme substrate complex. That is, here E represent the enzyme and S represent the substrate. Then enzyme and substrates are combined to form a highly reactive enzyme substrate complex. It is a fast reaction. K1 and K minus 1 are the respective rate constants of the forward and backward reaction. Then in the steps 2, then the enzyme substrate complex decomposes to product and regenerate the enzyme. Here K2 is the rate constant of the reaction and it is the relatively slowest step. So this step determines the rate of the reaction. And then rate of the reaction is equal to K2 into concentration of ES. And here ES is an unstable compound or high energy species. It is not able to determine the concentration of the enzyme substrate complex. So in order to calculate the enzyme concentration of enzyme substrate complex, we can use the steady state approximation. By applying the steady state approximation and based on this Michaelis-Menten mechanism, they derived an equation for rate of enzyme catalyzed reaction, that is R is equal to K2 E0 into concentration of S divided by concentration of S plus K minus 1 plus K2 divided by K1, or R is equal to K2 into concentration of E0 into concentration of E into concentration of S divided by concentration of S plus Km, where Km is equal to K minus 1 plus K2 divided by K1. This is known as the Michaelis constant. Here E0 is the total concentration of the enzyme, that is we have to know. Okay, S is the concentration of the substrate. So these two equations are known as Michaelis-Menten equation. Then the maximum rate of an enzyme catalyzed reaction is obtained when all the enzymes are participated in the reaction. That is, all enzyme molecules, that is all the total E0 is participated in the enzyme catalyzed reaction. At that condition, we can get the maximum rate of the reaction. Then maximum rate of the reaction is equal to K2 into E0. Then substituting for K2 R maximum for K2 into E0 in equation 2, that is the Michaelis-Menten equation, we can get the rate of the reaction in terms of R maximum. R is equal to rate at any time is equal to R maximum into S divided by concentration of S plus Km. So this is the rate equation based on the Michaelis-Menten equation. These three equations, first, second and third, represent the rate of enzyme catalyzed reaction based on the Michaelis-Menten mechanism. Here The K2 in equation 3 is known as the turnover number. That is the K2 when the concentration is maximum is known as the turnover, or rate is maximum is known as the turnover number. It is the number of molecules of substrate converted into product in unit time by one molecule of enzyme. That is, the number of molecules converted of the substrate is converted into product by one molecule of enzyme. Okay, that is how many substrates are converted into product by one molecule of enzyme is known as the turnover number. This is something about the enzyme catalyzed reaction and Michaelis-Menten mechanism. Okay, stop here. Thank you. Study well.